So
Just give me a second.
1 minute.
Just one second.
Yeah, I'm right. Yeah, I'm sharing the screen. Just looking. So, able to see my screen? Yeah, Musab. Hello. Hello. Yeah, Musab. Am I
Yeah, Prasad. Sorry, I got a call. I'm back. I'm very sorry.
okay? Okay.
Yeah, go ahead.
So, so yesterday we are talking about like VPC, right? VPC is one of the service that is provided by AWS. So
Correct.
VPC is nothing but your virtual private cloud. So what exactly
Correct.
you will do with the VPC? Like if you want to create your own network, right? You want to make it private, then we will use the service called VPC. Before going
Yeah.
to the VPC, what you required, what are the components that is available in the VPC? We have got that is divided into subnets, right?
Correct.
Subnet, and you will be having internet gateway and your route tables, and you will be having NAT gateway, right? You will be seeing like okay, NAT gateway is also called as a NAT instance. It is nothing but your instance only, and you will be having NACL, then security groups. Lastly, VPC peering. It's called peering. So,
Okay.
before getting into the VPC, these are all the components that is available for VPC. So, to create your own VPC, what exactly that VPC will do? It will it will determine your size of your network and it will divide the larger network into a smaller network. So, that is called your subnets.
Yeah.
Yeah, in order to have your VPC, in order to have,
That is a good.
pardon?
No, no. That is the subnet. Correct.
Yeah. See, let's say have a size of 10.0.0.0/24. So this is my VPC. This is your size of your network, whole network, right? That means
Correct.
that means you can create how many IP addresses? So what is the formula? 2 power
2 power 6
no, 2 power 32
or
minus 24. How much?
34,
2 power
30.
8, right?
Correct.
2 power
Like we have to 2 power 8 means 32 into 2 times.
not into, it's a power.
Uh,
Yeah, exactly. Sorry. That is 2
yeah,
power
that's what.
32 only, right? Yeah.
Correct.
Yeah, 2 power 32 minus 24 we are doing.
Yeah, minus 24. Correct.
Yeah, then you will get 2 power 8. So 2 power 8 is nothing but how many IP addresses I can generate? 256 IP addresses I can generate.
Yes.
So out of which 256, I want to make two subnets. Again, I want to divide it into smaller networks, right? Let's say I want to divide it as like 10.0.0. Okay. 256 means 128 and 128, right?
Correct.
This is again, it starts from 129. Then you will get like, uh, for this first starting IP address will be 10.0.0.0, okay, to 128. Again, it starts from 129 to 10.0.0.255. Okay,
Correct.
this is called subnet. Let's say 0 to 128 is subnet 1. This is your subnet 1. Say this is your subnet 2. So this is the range or address series of your network. So what I did, I just created, I want to create a VPC which is of size of network is 2 power 8, where I can get 256 IP addresses. Again, I want to divide it into a smaller network. Then I choose subnet as an, divide the 256 into two parts so that I can get one part is 128 and another part is 128. So altogether is 256, right? So I just
Correct.
divided the larger network into a smaller networks. So this is subnet. Then what is the use of your internet gateway? So as I said, if you are creating your own network or anything, do you think that it will communicate? So if your network wants to communicate outside the world, then what you require?
Uh, like we should be a public IP is required.
Yeah, that is fine. Public IP is okay for individual instance or for any server that you should require IP address of which is of public IP. So that
Public
is
IP.
fine.
Correct.
So before public IP, okay, that is that way anyway that will be assigned. But before IP address, I need a network. Like say, let's take example like in your environment, like whether it is development or testing or anything. I just divided that into a private network. No, I want to communicate from the developer team to a testing team. My machine is in development team and another machine is in testing team. Then how do they communicate?
Correct.
It
So
should,
they should communicate to
yeah,
this
some
thing.
LAN wire or something, but it should have a network, right? I mean,
Yeah, which will
internet,
the card. So anyhow, they will be having network. That
right?
is correct.
Yeah, we will be having router, switch, hub, and other part also we will be having same thing, right? Then we will have the
Yes.
common point as an hub, so that from development team it will connect to the hub, and from testing team it will connect to the hub. So by
Yes.
middle of them you will be having router switches. By passing through those routers and switches, that will connect to your particular machine or server, right? In the same
Yeah.
way, in AWS, we are creating VPC. but there is no internet. You are just launching a network, but there is no internet gateway is attached. So for that purpose, we have a service called Internet Gateway. So each and every time you are creating VPC or subnet, you need to create a IG, Internet Gateway W, that is called IGW, Internet Gateway, and you need to associate with the subnet and VPC. First, you need to attach to VPC, then it should be associated with the subnet, so that the machines or which you are launching in the VPC, they can have communication or outside the world by using the public IP. As you said, like it needs public IP, right? So by using that public IP, it is going to communicate towards the outside the world. So that is how it happens. Then what is the use of route tables? So we are talked about like VPC, subnet, internet gateway. Then why we need route tables? What exactly that do? Route table has the same functionality like what our router do in our homes or in any other networks in any organization. The same functionality which has got with the route table. So it main duty is to like it enroutes the incoming request or traffic to which instance should that request should go. So that is the duty of route table. So in route table, if you are attaching it to public, in general, when you are creating a VPC, you will be created default things like you will be that will be created like default route table. Okay, then default NACL
Correct.
and default security group. So
Yeah.
these are the three things that these are going to created by default. But in general, as I said, like you are creating VPC, you are creating subnets. In subnets also, you are creating one of them as a public and one is private, right?
Yeah.
One is public, another is private. So here, default route table will determine, it will attach to both the instances. It will not differentiate. It will, by default, it will associate as an public only, because it will, for a default route table, your internet gateway is attached or internet gateway is associated. So by this, what will happen? So if you got, for a particular instance, if you got an internet gateway means that is nothing but your public, right? But here I want to differentiate. I want public and private. Then how do you do? Here we need to create an separate route table. Then if you want a public, you can create, you can attach your internet gateway. If you want private, you should not. So that can be
Okay.
achieved by creating your own route table. So if you are using your default route table, what happens means, so whatever the instances that is, I mean, launched in subnets, so that will act as in public only. But you want to differentiate, right? You want to create your own, like you want to separate public and private. Then you need to create your own route table. So here route table will determine whether your request should go to the public or through via private. So that is what the functionality of route table.
Correct.
Then what about NAT gateway? What does exactly that do? NAT gateway.
Now it will like broadcast the network. It will like expand the network, correct?
No, it will not expand the network. Say, let's say I am saying like my have my own network, private network, right? In any organization that follow. Let's say, let's take example of like databases. So most of the time, like in any organization, the databases will be in private only, right? That will not be accessed by from anywhere or outside the world, right? So that should be
Yes.
private. So they will assign some private IP addresses to that particular databases. But I want to communicate from outside the world. That should happen, right? B, end user cannot see the what the logic behind the database, but he should access the database, right? From outside the world.
Yes, we should access.
Yeah, then how you can achieve, then how you can achieve and how the end user can access. So that can be done because your private instances don't have any internet, right?
Correct.
Yeah, each and every time we need to attach internet gateway. So do you think that it's a big task, right? For each and every time when I want to communicate with the internet, so I need to attach IGW to the private instance, then I will take the public IP, then only I can able to access my anything from outside the world. So it's a big task.
Correct.
So in order to overcome that, this NAT will help us. Like it will act as a like public IP only, but inside it will be private only. But it will transfer to router. It has a public IP. So it will pick up the private IP address. Okay, it will
Mm.
include the router, and in router it will determine key your IP address is acting as a public IP. By default, it will take one public IP. NAT gateway is nothing but your NAT instance only. It is acting like instance. There you will be assigned elastic IP. Okay, elastic IP is nothing but your public IP, right?
Yes.
Yeah, by using that IP address, it will send the request to the outside the world. Nothing but it is acting as a public IP. So by using this, whenever the private instance want to communicate to the outside the world, by using NAT gateway, it will communicate to outside the world. So that is a functionality of NAT gateway. So NAT gateway, in other words, it is an instance. So it will be assigned some elastic IP. So by using that IP, it will communicate to the outside the world. So that is a functionality of NAT gateway. Anyway, we have seen HG, right? Security groups. So this
We're taking host to another, just moving. So that is main purpose of NAT.
exactly.
Correct.
See,
Taking.
whatever the router you have. I mean,
Yeah.
even if you take I mean, if you take the example of your home router, you will be having a
Yes.
NAT and there only. NAT is in software, so that will become along with your router itself. So in general,
Yes.
your laptop or anything or any desktop, initially it will be having private only, right? Private IP.
Correct.
You will be assigned private, right?
Yes.
When it goes to router, it becomes public. How? Because inside the router you will be having NAT. It will translate your IP, private IP to the public IP. Then only it can communicate to the outside the world. So this is what happens in even at your home also in any organization. Initially you will be assigned only private IP only. But to communicate outside the world by using the NAT gateway or NAT address translation. So it acts as a public IP and then it will communicate outside the world. So this is what happens. So this is a mechanism that it follows.
Okay. Okay. Got it.
So we have seen like security groups at our EC2 instance, right? So how to create
Yes.
the security groups and there's I mean two things, right? Inbound rules and outbound rules. Whereas your inbound rules is incoming traffic, right? Whereas outbound is whether your EC2 instance wants to communicate with other EC2 instance. So that is what we have seen. So we'll see like NSEL. We'll discuss later when we create our VPC. NSEL is nothing but NACL where you will be applying access control list at your subnet level. We have seen SG at EC2 instance level, but here NSEL is at subnet level, your network level. So when
Okay.
you want to communicate with other network or not, you're just giving the permissions like access control. So this is our again next level firewall, I can say. So this is firewall at your instance level. So this is firewall at your network level, NSCL. That is called
Correct.
network access control list. So anyway, we'll be discussing. Then what about peering? So what is peering? Let's say I have created VPC 1. Okay,
Okay.
VPC 1. So in VPC I created like subnet 1 2, subnet 1. Okay, subnet 2. Let's say in another VPC, VPC 2 just created subnet 1, subnet 2. Let's say in subnet 1, I created only private IP. Sorry, one is public. Okay, I1 is a machine of public IP, public subnet, and this one is private.
Okay.
Your I2 machine is
Right.
I2 is private. In the same way, I created here only private. This is one. This one is private. Okay, this one is also private. So, will I able to access this I1 machine with this I1 machine of VPC2? Is it possible? Because this one is different network and this one is different network.
No.
Because you don't have any communication, right? So,
Because we don't have, this is a network, then it's on different network, this one is in different network.
so
That's why we cannot able to access that one.
yeah. But in general, within the VPC, any instance or any server that will have a communication. But here we got two different networks. So I'm just trying to communicate with I1 to I1 machine of VPC, other network. So in order to have
Correct.
communication between these two networks of two different EC2 instances, so I will be using the service called peering concept. So in order to have a peering concept, peering connection, this IP address or CIDR block notation should be different. Otherwise, there is a chance of overlapping.
Okay.
What exactly it is called? This is called your CIDR block notation, right? See,
Yeah.
whatever the range and slash 24 that I am giving, this is nothing but your CIDR block notation. So this CIDR block notation should be of different number, so that you cannot have any overlap. Otherwise, there is a chance of overlap. So once you get overlap, you are not allowed to do. Or you are not allowed to create a VPC. So these are the concepts that are involved in VPC services. So when it comes to subnets, there are few, conditions like, so subnets can span across only one availability zone, but you can create multiple subnets in one availability zone. And there is also called one default VPC created per region. Yesterday we have launched EC2 instances, right? Till now, do you think that you have created a VPC there?
No. VPC was not created.
Yeah, that VPC, any instance, anything that we are creating, so that will be under VPC only. In AWS, everything will be under VPC because this is private, right? Your cloud is in private.
Correct.
AWS itself is in private zone. So, in order, whatever the instances you are creating, so that is by default, That is under VPC. But what we are talking about today's session is like VPC. If you want to create your own VPC, we need to follow these things. So these are the components available, right?
Correct.
So these are the components we need. So initially we talked about like how do we get IP addresses, what is the CIDR block notation. So how we can divide that particular IP addresses into smaller networks. See here you no need to worry about like calculation. You will be having some sites, right? Will show one side. You can go and subnet calculator.
Correct. Subnet calculator will be there. You are right.
Yeah. So no need to worry. But
Subfile.
there is, I mean, you need to understand. See, you will get everything. One minute, I will show one of another one. Yeah, this will be good. David C. Let's say, what is the range I given now? 10 dot 0 dot 0 dot 0 slash 24.
Zero.
I gave slash 24, right?
Yes.
See, this is a range of IP address. So how many IP addresses I'm getting? It's starting with 10.0.0.0 to 10.0.0.255. Now I want to divide this VPC into two subnets. So just go and click on divide. So what is the range you are getting? So one is of 10.00.127. It is ending with dot 127. Again it is starting with 128.
Correct.
I've shown the same thing, right?
Yes.
Okay. Did you observe anything here? Usable IPs? Why not these many? It should supposed to be how many?
It should be like 128 plus 128 should be like this.
Yeah. So in general, what happened? Out of 256, out of 256, here you can use only 251 IP addresses. Your 251 IP addresses can be assigned to your particular machines. So what about 5 IP addresses? These 5 IP addresses are reserved. So out of 256 IP addresses or any IP addresses, any range, if you take, out of those, your 5 IP addresses will be reserved. First 4 IP addresses and last one. See here you can see
Yes.
here first you are not using 0 and the last one 127, right? In general it is first four and last one is not usable. So that is for mainly your broadcasting or network, and you will be having some uh, available network. So those are reserved for that. You need to broadcast, right? You will be having some broadcast network or multicast network, and those IP addresses are reserved for those. So only you can be usable out of 125, sorry, 128, any IP address range, that is your 5 IP address will be used and remaining will be used for your particular machines. Let's say if it is 256, you can use only 251 IP addresses. So out of which 256, 5 IP addresses are reserved.
Correct.
Yeah,
Because those are reserved IP addresses.
yeah. So that is by default.
There
That is taking
will
with
be some loop. There will be some IP address. I'm remembering like some loop back something like it will be common. It will be kept one IP address common like 128 or some. I
that
learned this method.
that is called 127.0.0.1.